This is Eric Chappell, Civil Community Evangelist for Autodesk, and today I want to talk to you about what's new in Autodesk InfraWorks 360. I'd like to break down the capabilities of this new release of InfraWorks 360 into several key areas. First, we'll talk about how this new release lets you more than ever work like an engineer. Following along those same lines, we'll talk about the serious road design capabilities that have been added, including expanded bridge capabilities as well. We'll talk about point clouds and how you can do more with them than ever before. We'll discuss and demonstrate how flood simulation capabilities are now part of what InfraWorks 360 offers. And then finally we'll talk about a new feature set, legal boundaries. Actually, they're called areas of interest, but as you'll learn, their primary application is for representing legal boundaries in your model. And then as a bonus, I'm going to tell you about another new feature, but I'll save that as a surprise until the end. Let's jump into how this new release of InfraWorks 360 lets you work like an engineer more than ever before. The newly released InfraWorks 360 views allow you to easily control what you see and how you see it. Out of the box, the software comes with two built-in views, conceptual and engineering. And you can see how these samples are built so that conceptual view is much more visually stunning with real materials and animated clouds, whereas the engineering view is more simplistic and turns on features like surface opacity so that I can see beneath the ground to the bridge substructure. Now I can completely customize these two views, and I can even add my own views. For example, I can create one called wireframe and simply turn on the wireframe capability, and now I'm able to switch between three different views: conceptual, engineering, and wireframe. Why is this feature important? It lets you easily control the realism of what you see versus the engineering detail that you see at any given time. With the new release of InfraWorks 360, showing contours is as easy as flipping a switch. When I click this area of interest and turn on the contour display, I immediately see the contours. And they reflect not only the GIS data representing my terrain, but also the design road that's cutting through it. And they, of course, are dynamic. If I make a change to the design of the road, for example, lowering this PVI to change its elevations, I see that change reflected in the contours. I can also affect the interval of the contours. Currently they're set to 2 feet. I'll change them to 1, and just like that we see the new interval represented on screen. Why is this feature important? It allows you to see the engineering detail in your design in the form of contours. With the new release of InfraWorks 360, you can easily view the cross-section of your road design. You can change the position where the cross-section is being viewed, and you can also pan and zoom within the cross-section window. The cross-section window itself has several different views, including super elevation view, road assembly view, and cut and fill view. Here you can see as I move the slider from an area of cut to an area of fill, while at the same time the section view window is providing information about the amount of cut or fill at any given point. You can also control the aspect ratio. Why is this feature important? It allows you to see the engineering detail of your design in cross-section form. With the new release of InfraWorks 360, you can calculate earthwork quantities at the click of a button. With a conveniently located earthwork quantity calculator in the bottom right corner of my screen, I can easily get cut and fill values for this road. If I want to see detailed values, I can bring them up on screen, or I can export them to a report. Settings allow me to control the station increment and whether or not sampling takes place at key stations. And of course, if I make a change to the road, it's very easy to recalculate my cut and fill quantities, so I can easily work toward achieving a balance or whatever my earthwork quantity goals are. Why is this important? It allows me to easily assess the cost impact of my design as I work. With the new release of InfraWorks 360, you can easily configure the units that are applied when you get important information from your model. You can control the unit and precision for many types of values. Notice how each value in the model is respecting the unit and precision settings that I adjusted just a moment ago in the unit configuration dialog. And you can easily switch between imperial and metric, and your configuration is stored for each unit system. Why is this important? It allows you to get each value that you need in a practical and efficient form. Now let's take a look at how this new release of InfraWorks 360 allows you to do some serious road design. With the new release of InfraWorks 360, you can build roads using smart components like lanes, curbs, and sidewalks. Each of these components can be configured independently, as is being done with the sidewalk in the current example. You can also insert new or different components anywhere along the design. Watch as we insert a new lane component to create a bus pull-off to serve our residential development in this example. Not only can we add the extra lane for the bus pull-off, but we also can configure its geometry and other properties to make it fit just the way it needs to in our current project. We can add a bus for a little bit of realism, and just like that, we've got a modification to our design that includes the bus pull-off. Why is this important? It allows you greater flexibility in your road design to meet more project needs. Let's take a look at some other things that you can do with component roads. For example, you can use templates to apply a complete road configuration at once. Watch as we take the current road configuration and store it as a template in the library, and then apply it to another road in the same project. We do this by converting the style-based road to a component road and then simply choosing the component road template that we'd like to apply in the conversion process. As you can see, in just a few seconds, not only have we converted this road to a component road, but it also has the components and configuration of the road we were designing just a few minutes ago. Next, we'll take this road and add some detail to it by providing some trees along the right side. Note that this could be anything. Trees, obviously, but also light poles, guardrails, or anything that you have access to in the form of a 3D model. Why are these capabilities important? They allow you to design roads not only efficiently, but also with the ability to address detail. With the new release of InfraWorks 360, you can add roadside grading to your road designs. I'll start by changing the grading method from fixed width to fixed slope. You'll see now that InfraWorks 360 is providing a 3-to-1 constant slope on both sides of the road. I can also click one side or the other and have settings that apply to just that side. For example, I could change the cut and fill slopes to 50% for this side of the road. And perhaps the reason I'm able to do that is because I'm applying a more stable material on this side of the road, which I'll represent by changing the material applied to the side slope. So here you can see an independent application of not only the slope but also the material that's different on the right side of the road than it is on the left. Why are these capabilities important? They allow you greater flexibility in your road design to meet more project needs. With the new release of InfraWorks 360, applying super elevation is as easy as flipping a switch. I'll turn on super elevation for this road, and once the calculations have been applied, I can see by looking at the cross-section view that I now have super elevation applied to my road. Not only that, the on-screen graphics help me understand what's going on. I have these section markers at key stations, and I've also got this colored banding that shows me the runout and runoff area associated with the super elevation calculations. Now, most of this is based on a built-in design standard, but I can also go into the contextual stack and change some key values such as the maximum super elevation rate or the amount of runoff that takes place in the spiral. Why is this important? It allows more advanced capabilities to meet more project needs when it comes to road design. InfraWorks 360 has the ability to automatically create a pavement drainage network for your road design. And in this new release, not only is it able to do this, it's able to understand the complex geometry offered by component roads. As we take a closer look at the pavement drainage system that's been automatically laid out, we see that it's smart enough to recognize that the inlets need to switch from the outside to the inside because we're entering a super elevated curve, and now the inner curb is the downstream side of the road. Also, you'll notice that inlets have been placed in the swale running down the median of the road. Why is this important? It allows more advanced capabilities to meet more project needs. Let's take a look now at how you can do more than ever with bridge design and analysis in InfraWorks 360. Bridges in this release of InfraWorks 360 have a sophistication that matches the component roads. Watch as I create a bridge on this rather complex cross-section, and the bridge is able to recognize the complex geometry of the component road, including the divided 4-lane road, the sloped grass median, and so on. Next, you'll see how I can replace the geometry of the bridge with a different assembly, and yet it still matches the complex configuration that comes with component roads. Something interesting to note is that this bridge respects not only the complex geometry of the component road, but also the super elevation that's been applied to this road. As you can see, the lanes are super elevated on the bridge to match the road. So bridges are able to recognize and handle the complex geometry offered by component roads and super elevation. Now let's take a look at the bridge itself and the fact that it's in some ways a component-based design also. If I click the bridge, I have the ability to go into component display, where I can turn on or off different major components of the bridge, such as the road, the deck, girders, and so on. I'm going to limit my view to simply the deck and the girders. And you can see when I click the bridge to select it, my display is limited to the components that I want to see. Now another aspect of this component behavior is that we can actually edit certain components of the bridge in a very detailed fashion. For example, I can click the deck and change values on the deck itself, such as the thickness, edge thickness, tapering, and so on. So the bridge deck in this case behaves much like one of the components when we're dealing with component roads. Now another added benefit that I have is that I can add additional cross sections. If I click this starting slice gizmo and then the plus sign, I can add a new slice at a different location. And the dimensions of this slice can be independently controlled, so that if I want to do something like change the thickness, and I'll use something dramatic here, 8 feet, so that we can see it very clearly, I can actually have a varying cross section throughout this component. And there you can see the result of adding that additional slice. As you might expect, I can click the slice and move it to a new location, and that transition point along the cross section of the component will move with it. I've got a similar capability with girders, so let's turn off the deck and turn on the piers. And if I select a girder, I have the same capability where I can add an additional slice and change the dimensions for that point along the cross section of the component. So imagine the possibilities of being able to modify the cross-sectional geometry of the deck and girders on a bridge. So why are all these new bridge capabilities so important? They allow you more detailed control of your design to meet more project needs. With the new release of InfraWorks 360, you can verify the structural strength of bridge girders by performing a line girder analysis. Now that the analysis is complete, I can click on individual girders within the model to view information about that girder. We can also see the color coding that's been applied to the girders, indicating the performance of the girders. Notice the girders in red indicating a problem with the girder design, corresponding with values that show up in red in the results. If I click one of the girders that is not color-coded, I see that none of the results end up in red, telling me that these particular girders have an acceptable design. Now, if I want to get more detailed information about this girder analysis, I can click the Get Full Report button, which links me to a purchase dialog, which currently is free, so I can simply click Complete Purchase, and a detailed report will be produced for me. The report ends up on my desktop in the form of a PDF, and I can scroll through it, or I can navigate the table of contents to view the different information available in the report. Finally, I can take this information and open it in Autodesk Structural Bridge Design to continue with the detailed design and documentation of my bridge. Why is this line girder analysis capability important? It allows you to go deeper into your bridge design so that you can get to detailed design faster. Now let's take a look at how you can do more with point clouds in InfraWorks 360 than ever before. With the new release of InfraWorks 360, I can turn a point cloud into terrain data literally with the click of a button. InfraWorks 360 will analyze the point data in my model and use a series of settings to determine the best way to turn that point cloud not just into surface data, but also into vertical features like signs, light poles, trees, and other objects. And this just isn't converting a point cloud into something else. It's also processing the point cloud and giving me options to export it as either its original form, a lightweight version, or one containing just the key points in the point cloud. And I can export this data either to another proposal in my model or even out to a separate RCS file somewhere on my hard drive. I'll go ahead and click Start Processing, and once the process is complete, you'll see how the tool takes this very rough surface that I built from GIS data and turns it into something much more accurate based on the data stored within the point cloud. And not only that, it has set the stage for me to begin extracting objects from this point cloud, such as light poles, signs, and trees. Why is it important to be able to extract terrain data from point cloud data? It allows me to make practical use of my point cloud data to establish accurate existing conditions. The new release of InfraWorks 360 will automatically recognize objects in the point cloud data that I've brought into the model. All I need to do is click a button, and InfraWorks 360 will automatically pick out these objects and insert model objects in their place. Not only that, I have the flexibility to adjust whatever InfraWorks 360 has done for me. For example, in the sample file in front of you, we've taken two light poles and swapped them out with power poles, which are the correct representation for those objects in the model. And you can see how easy it is to switch out the different objects and to make adjustments to their size and shape so that we can accurately match the point cloud. Why is this important? It allows you to turn point cloud data into model objects quickly and easily. Let's take a look now at a new feature set in InfraWorks 360, Areas of Interest. As you're about to see, these are great tools to use to represent legal boundaries in your model. With the new release of InfraWorks 360, you can use areas of interest to represent parcels, easements, and right-of-ways. And you can do this by drawing them in the model or by importing data. To show you how to draw in the model, I'll show you a handy tool for creating right-of-ways. When I launch the tool, I'm given a few options as to how to create them, and the most useful one is road offset if I've got design roads in the model. Now what I'll do here is say that I want the same offset on both sides and that value is 25 feet on either side. Now it's just a matter of double clicking the design road, and just like that I've got a right-of-way in the drawing. Now as I mentioned, you can also import data into these different object types. To do that, I'll go to the Data Sources command and add some SDF data. And you'll notice when I configure the data, I now have the choice of parcels, easements, or right-of-ways. For this particular data set, I'm going to use parcels, and I'll use a style that shows the parcels in a nice dark blue color. And just like that, I've got parcel data and right-of-way data in my model. Not only can I represent these items in my model, but they also have separate property types, which means they show up separately in Model Explorer and they have their own properties. So for example, I can click this right-of-way and see its area and perimeter. I can also use Model Explorer to turn off the parcels and then turn off the right-of-ways as well. So why is this important? It allows you to represent legal boundaries and other linear features in your model. Next, let's take a look at how flood analysis and simulation have become a part of this new release of InfraWorks 360. If you've got the latest release of InfraWorks 360 and Hydronia Riverflow 2D, you can run a flood analysis and simulation right in your InfraWorks 360 model. I'll start by defining the boundary that I'd like to study for my flood analysis. Then I'll define the inflow and outflow locations, and then provide the necessary values to run the flood analysis. I'll click Run Simulation, and once the simulation is complete, I can play the simulation in the model, analyzing water surface elevation, depth, or velocity. Here we see a very visual and easy to understand animation of the change in water surface elevation over the 2-hour period, and then again with depth. And that's the beauty of this tool, how easy it makes it to communicate the flood analysis results to others. I can pause and create a snapshot, and then restore that snapshot at a later time. This allows me to easily communicate the results of my flood analysis anytime I need to. Why is this capability important? It gives you the ability to perform a flood analysis on any one of your projects quickly and easily. As promised, I'm happy to announce a bonus feature in InfraWorks 360, recently used styles. The new release of InfraWorks 360 saves you time by always remembering the last few styles that you've used. Let's see how it works. I'm going to click this car and change the style of it to, say, a taxi. Then when I go to change the style of the car nearby, that taxi style is remembered and placed in this list of most recent styles. So now I don't have to browse for it to find it once again. Let's see how it works using this house as an example. I'm going to change the style of the house to this 2-story stucco, and then I'll change it back again to the Tudor style that it was previously. Now when I click the style icon again, I see both of those styles listed under most recent styles. So why is this feature important? It saves you time by preventing you from having to browse for your favorite styles. So now that you've seen all these great new capabilities of the latest release of InfraWorks 360, how do you get your hands on it? Well, the easiest way is to go to your Autodesk desktop app and look for the update to InfraWorks 360. Or you can go to manage.autodesk.com and look for the link to the new installer there. If you're not currently an InfraWorks 360 customer, you can still get access to all of these exciting new features and more by downloading a free 30-day trial of InfraWorks 360. I hope you're as excited about these new features as I am. Thanks for watching the video, and once again, my name is Eric Chappell, Civil Community Evangelist for Autodesk.